Hello everybody. Today I'm going to be quickly going over alcohols and a little bit about ethers as well. So what makes alcohols special is that they have this hydroxy group on them. Hydroxy is just the OH. And because of this hydroxy group, alcohols with shorter carbon chains are capable of hydrogen bonding. Hydrogen bonding is the weakest form of bonding, but it's super important because I don't think I'm drawing this shape right. There we go. Because it allows for water solubility, more specifically with the oxygen here. So let's say we have a short carbon chain. I don't think I drew that right. It is now able to form hydrogen bonds, these hydrogen bonds right here, which are represented with dashed lines, to become soluble with water. Now what happens when we have a longer carbon chain is that this non-polar piece here, the alkane part, overpowers the polarity of the hydroxy group. So it's either going to be water soluble not as well or not at all, depending on the length. So remember, here is the nonpolar and polar. Something important about these alcohol groups is that they can do dehydration reactions. So let's say we have ethanol, which is a 2-carbon alkane chain with a hydroxy group attached. Also, your alcohol. So as we know, the carbon at the end here is going to have 3 hydrogens, and the other one, which is attached to the hydroxy group, is going to have 2 hydrogens. Let's make that like a super bright. It's important to look up because I'm using colors now to describe what's going on. Now, this dehydration reaction is going to happen in the presence of heat and an acid. And the acid I see in all my examples for school is H2SO4. And we're going to need 180 degrees Celsius for this to happen so that this ethanol can become a ethene. That's with the double bond. It breaks the bonds here so that we can have a double bond between the 2 carbons. And now you see we have room for 2 hydrogens on each carbon, and the hydroxy and the other oxygen that I have over there in light blue come off and become water. So dehydration, because you're breaking off a water from this alcohol. So what happens if we have, but still dehydration, I'm just erasing the words for more room. What happens if it's a little less hot? So let's do 140 degrees Celsius, and we're going to need 2 ethanol here, but I'm going to have to change the colors a little bit so it can make sense. We'll keep up with the light blue for the part that's going to break off and become water, and a dark blue for the rest of the components that are going to stay attached. just the hydrogens that are going to stay on, they're implied. So when you have this acid up here, along with 140 degrees or 130 degrees of heat in Celsius, what's going to happen is that the water breaks off. We knew that, it's dehydration. And a bond forms between this one oxygen that's left over and the two alkane parts. You see what's important here is we have this C-O-C chain going on. That is what defines an ether. So when you have dehydration of two alcohol groups with acid 140 degrees Celsius, you form an ether. This ether right here is called diethyl ether. The naming is pretty straightforward for this. So let's say we have this group right here. We're going to do the name of the branch on the left. So this one's going to be methyl. The branch on the right is propyl with spaces between, ether. Methyl propyl ether, which is going to be formed with methanol and propanol. Let's do one more example real quick of this. How about a isopropyl and we'll just do another ethanol too. On top of your reaction arrow, H2SO4. Below it, 140 degrees Celsius. And of course we got H2O. And it's going to be, I guess since I said the isopropyl first, we have isopropyl ethyl ether. And the parts of our two alcohols that are coming off to form, it doesn't matter which oxygen you choose to be part of the water. We're going to have one of the hydrogens from the hydroxy group and the whole hydroxy group from the other alcohol coming off to become the water in the dehydration reaction. And that pretty much summarizes alcohols and a little bit about ethers. I do not know too much about ethers, to be honest with you. Next, I'm going to go over, I think it was aldehydes and ketones, yes, which are defined by a carbonyl bond. So stay tuned.